Hello, welcome to our group presentation with Team 2D Letter Printer. And Group members are Jace Parsell, Campbell McGavin, and myself, Robert Auer. Let us begin. So, with our group presentation, what we'll be covering is the purpose of this project, how we decided to um, create a 2D letter printer, or how we found a problem and then designed a solution around it. And we'll also be covering the design of the project, the mechanical assembly of the machine, along with the coding that went into it to get to work. As far as the inspiration of this project goes, we in the beginning were divided on what we wanted to do, and we came up with three different projects that we thought would be interesting, each with their own different unique spin on things. And what really drove the our decision on a single project is the simplicity of the project, how possible it was to do within the time frame that we were given. And what really made the 2D letter printer stick out to us is that one of our group members really wanted to have one of these CNC machines for personal use, so we decided to go along with.
Okay, so for a quick overview of the mechanical components of our project, pretty simple concept in general. Item one, we had the steel frame that Jace, our teammate, had went above and beyond on. He actually welded the steel pieces together at his house and then shipped the frame over to a local shop that powder coated it, which is that nice shiny coat that you're seeing. Uh, Item two are a combination of steel rods and just smooth gliding rods that allows the motors that super accurate control that we talk about in the report. Item three is the X motor that moves the entire gantry. And then item four is the Y motor, which is actually located on the tower of the gantry itself. And it moves that little rectangular thing left and right, giving 2 degrees of freedom on a 2D drawing surface.
With designing our project, we had one big idea in mind that was abstraction. Basically, what that means is to take a large idea or a large problem, break it down into smaller problems. And we did that by designing four different classes, each of them with their own job and a unique way they interact with each other. So with our four classes, we have setup and user input, with the movement, drawing, and motor control. So with setup and user input, this is how we initialized our whole entire program. And this involved things such as go home function, which is how we homed our two stepper motors to a consistent starting position, with a limit switch being used with our homing system. And what the limit switches do is they send out a low frequency until they are flipped on. Then they send a high frequency, and basically all that means is until the stepper motors start touch those limit switches, they will always be sending low frequency, and they will stop once that high frequency has been sent. We also have a main menu set up with our setup and user input as well, which is how the user is able to interact with our CNC machine and feed it inputs. Moving on to movement, this is just how we are able to um, how we control the movement of the stepper motors with functions such as are we there yet for both the X and Y axis, and just checking the distance between the location of the stepper motor and its prime or its destination. And all it does is tells the motors where to go. Moving on to drawing, this is where we have our symbol library, where we currently have the English lexicon hard coded in. And how we did this is using a grid point system in which we have 26 points, 26 point array, which stores different values that we're able to use. And what that does is just allows us to easily create new symbols um, using this grid point, such as if we want to create, if we tell it to go from point 1 to point 25, we'll be making a diagonal line without having to hard code that in since it's already done. And what this does is just allows for easy accessibility and adding of new symbols in later on. Moving on to our motor control, that is just basically telling the motor to stop and go, along with controlling the speed of the motor. So it's just works in tandem with our movement. And yeah, that's pretty much.
Okay, so on the wiring overview, also trying to make this high level, easily understood, we had a 5 volt relay, sorry, a 5 volt power source controlling a relay, and then a 12 volt power source for usable power for the Arduino. Make sure it didn't have that magical white smoke. 48 volt for the Y motor because it just wasn't pushing nearly as much, and then an 85 volt for the X because it had the whole entire gantry it needed to push. Then we got our converter that dropped the 12 volt down to 9, which was more in the recommended range for the Arduino. Got the Arduino itself. And last but not least, we used limit switches for the motors to recognize when they were at a home position to reset the position variables in our code. Wiring table, short of the long, 2 pins for X motor, 2 pins for Y motor, one to give it power and the other to give it direction, basically. And then on the X switches, there was 1 pin for each limit switch.
In this section, we will be going over how we divided such a large task into smaller sections and the roadmap that we laid out for ourselves in order to accomplish this. So starting off with our decision process, in the beginning we were stuck between 3 ideas: a laser tack kit, a Skittle sorting machine, and a 2D CNC machine. So we all agreed to the CNC machine, but we had a worry about being able to complete it on time. So we set a deadline for that to say, if we believe that we have made enough progress at this point, we will continue. Otherwise, we will move on to one of these smaller projects. And luckily, we were able to meet that deadline. Moving on to our timeline, we devised this project into 4 sections: design, assembly, coding, and completion. And going off of our abstraction idea, we were able to divide this big project into 4 smaller pieces and making it much easier to work off of. So with design, what we did to accomplish this was we sat down and actually designed the wiring and the frame along with of our actual CNC machine, along with talking about what we wanted our code to do to work with our CNC machine. So with the Campbell took lead with drawing the diagrams for our wiring, and Campbell was able to get a list of materials we needed, or sorry, Jace was able to get a list of materials needed for the CNC machine that was needed in order to assemble this. So after we were able to complete that, we moved on to the actual assembly of the machine with wiring everything and getting the frame assembled and later power coded. So with this, Jace took lead with ordering all the parts and assembling the frame, just because he's the one that is going to be using this after this is all done, while we all work together on getting the power source and the stepper motors wired properly to be used. Moving on, once we were able to successfully get the stepper motors wired correctly and our frame assembled, we moved on to coding. And what we did here is we laid out a roadmap that we wanted to use on what our code needed to do and how we were going to accomplish with that. And what we did, we all worked together on that, finding resources that we could use along with designing our classes. And what we did was we got a inspiration from the Excel Sepper Arduino library, which we used in our code, and we also added a homing function, which would allow us to home our motors to a starting position every single time once we started the CNC machine. And once we got our coding, our wires assembled, and our frame put together, then it was time to bring everything together. And how we managed to do that was we combined our code along with our wiring and our stepper motor, or our frame to our stepper motors, and we actually put this into action. And with it, we were able to create a full symbol table that we're able to print and scale, all using the Arduino Mini. It uses a 26-point grid, which we're able to feed in points that all that can be dynamically changed depending on how long the string was given to the Arduino Mini.
High level, a couple of the major problems that we encountered. We actually had a surprisingly difficult time deciding as a team on what project we wanted to do. We had some really good ideas. We thought we could do a laser tag set with different game modes. We could do a Skittle sorting machine that used infrared light to size up a Skittle based on color, and then it went one way to the left or the other way to the right, dropped into a bucket. Or a 3D CNC machine. And we had some pretty candid disagreements and conversations about what was reasonable, what was in our scope, and felt like a good enough complexity to meet the requirements. So, disagreement, discussion, compromise, consensus, and we were able to decide on a 2D CNC machine, so a little bit lower complexity, that still meet the scope of this class and that we felt was doable with the time frame that we had. Next, the interfacing with stepper motors. We probably spent, apart from the mechanical design and welding that Jace did so excellent with, 15 plus hours figuring out how the stepper motors worked. So that entailed how to wire them to receive proper instructions from the Arduino, how to make them just go, how to go backwards and forwards, and then how to go a set distance based on the internal information that the motor was keeping regarding distance. And then lastly, the idea of the X and Y motors to be able to work in tandem as a team to draw with a writing utensil. And the last challenge, probably the greatest, was halfway through the semester, we were not able to work as a team in person. So we had an alternate plan of just using Google Hangouts. And it actually worked quite well. We were able to do some pair programming and try and help out with wiring. But again, Jace was a champ, and he led the pair programming so that we could easily upload the code from his computer to the machine which was housed at his house.
Okay, so our project was a CNC machine which works using fancy electromagnets known as stepper motors, which take computer signals and then converts it into rotational energy, which when attached to a lead screw becomes linear motion, enabling us to use like a coordinate-based system to draw out things. Most CNC machines use 3 axes, but due to Corona we were unable to implement our 3rd axis, so this is our little makeshift solution, which it is slightly too far away to write. And now it's working. Okay. Yep.
Lessons learned. In summary, machines have superior accuracy, especially stepper motors. We speak about this in our report, but the human hand, traditional stepper motors, it would be very difficult to do what you just saw in the demo, whereas stepper motors just have such fine-tuned control and repeatable, reproducible results that would be almost impossible for the human hand and much more difficult and require additional parts to get the accuracy from a traditional motor. Abstraction. This was huge. Not that our problem was like the most complex thing ever solved, but it had complexity to it. We were able to use abstraction to break apart our problem into little bits and levels and reduce it to building blocks that were very low complexity, that had input, output, expected result, and when we figured out that, it was much easier. Lastly, effective teamwork is the key to accomplishing expectations. First couple weeks, we might have had some just alignment issues and trying to understand each other's communication styles, but after we figured out the team dynamic, we were effective and efficient and time frame based, and we all headed up our different items and were able to get a finished product that worked and met the expectations of this class. Anyways, thank you, Professor McGavin, for your time. Wonderful semester with you, and If you have any other questions or concerns or would like to express any of your thoughts regarding this project, please reach out to us. We'd love to hear it. Thank you.